Okay, guys. So what we're looking at to start today is super important. I have seen in years past that students that struggle with this down the road have a really hard time with certain concepts. So the sooner we can figure out how to name angles and how to reference angles, the better you're going to be in the long run. So first off, what is an angle? Well, an angle is formed by two rays with a common endpoint, and that common endpoint is called the vertex. And so when we look at our picture on the left, V is considered, or is, your vertex. Those rays are just called your sides of your angle. And in our picture, the two rays that form the side, remember rays, it's important to start with the endpoint. So you have ray VA and also ray VC. One of the keys is whenever you are in doubt, you always, always, always want to name an angle using 3 letters. That will never be wrong for you. The key is that the middle letter must always represent the vertex. So the vertex, I don't know what's happening, guys. I'm sorry for this. There we go. The vertex is that middle letter. So in the picture, we have angle ABC, or we have angle CBA. One of the easiest ways to go about naming these is to literally trace the angle as if you're going to draw it without picking up your pencil. So for example, I would start at A, go through B, and then go through C. So that is ABC. Or I can go backwards. I can start at C, go to B, and then go through A, and so I can name that CBA. But again, that middle letter has to be that vertex that we've talked about. Notice that the only time you're using a single letter is if there's only one angle located at that vertex. So in our picture, that vertex is B, so we would call that angle B. Notice we do have that symbol for that angle in there. That's super important to reference that angle itself. Okay? Notice when it says when referring to the measure, we're using lowercase n. So I would read this as the measure of angle ABC. So when you see that lowercase n, that's talking about the measure of that angle. The types of angles you guys have probably seen in the past. The key is it's all geared off of a 90-degree angle. So if we look here, this is called a right angle. The measure of the angle is equal to 90 degrees. Here we have an obtuse angle. The measure is greater than 90 degrees. That's a greater than. And then here we have an acute angle where your measure is less than 90 degrees. Okay, so those are all kind of geared off of that 90-degree idea. Now, when we look at these, we're just going to name a couple things here. When we look at this, name the vertex of the angle. We're just looking at point K, where that corner of the angle is. Name the sides. Again, sides are rays, so we have ray KJ. Don't forget that symbol on top pointing to the right. And we also have ray KL, again, symbol pointing to the right. Give 3 ways to name the angle. So we have angle K. There is only one angle in this picture, so we can name it with that single letter. We can also name it as angle LKJ. Again, that K has to be the middle letter. Or we could name that backwards, JKL. If it says to classify the angle, that's going back to the acute, obtuse, or right. This is greater than 90 degrees, so we would call this an obtuse angle. One of the things that I want to go back and touch on really quickly is there is another way to name an angle, and sometimes what you will see in some angles is just a number. So not the angle measure, but just like a number. So you might see like a 2 here. You could also use the number. Not the measurement, but the number. So for example, we would call this angle 2. So if I were to look at the one that we were just looking at, maybe I would see a 3 in here, and I would call that angle 3. So you could use that number. You will see that in some diagrams. I just want to make sure you are aware of that. Okay, so when we have this is pretty extreme. There's a lot going on in one picture, so we have to be really intentional about what it's asking for. So name the vertex of angle 2. That's that point T that you see in the middle. So that is our vertex. Name the sides of angle 4. So if we look at angle 4, it's starting at T, going through W. So that's one ray. and then starting at T going through Z, that is the other way. What's another name for angle 3? Well, again, we have multiple angles going on here, so we cannot just use a single letter. So instead, we have to either go U, T, Z, so angle U, T, Z, or I could go backwards, so angle Z, T, U, but again, that T has to be the middle letter. Write another name for angle 1. Same thing, we cannot just use a single letter because we have more than one angle going on here. So when we look at this, we could go angle X, T, Y. And again, you could have those in the opposite order. Name the sides of angle 5. Angle 5, we're looking at T through Y, so that is one ray. And then we're also looking at T through W, so that is our other ray. When we see that word classify, again, what we're looking for in that is whether it's acute, right, or obtuse. So we're looking at angle Y, T, W. So Y, T to W, we see this angle marking there. That represents that it's a right angle. So that would be a right. Again, we're looking for that box that I just circled as an indicator. If we look at letter G, Y, T to U, that is an obtuse angle. It is greater than 90 degrees. If we look at X, T, U, so we're starting at X, going through T, ending at U, that is an acute angle. It's less than 90 degrees. And last but not least, we're looking at W, T, U. So W, oops, sorry guys. W, oh, there we go, T, T, U, that is also obtuse. Okay, so it's going to be super important that we recognize those as we start looking at examples and making sure we know which angle it's referencing. Okay, so kind of to take that to the next level then, and then we're combining what we did with segment addition the other day, and now we're going into angle addition. So if we look at our examples, I'm going to do a couple from your worksheet, so if you don't have that out, you want to pause the video and get that out for yourself. When we look at measure of angle KLM, that is what it's asking us for. So if we know KLB, if we know this small angle is 26 degrees, and we know that BLM is 60 degrees, we're trying to find, the part that we're trying to find is the big angle. So again, we're going to use that idea that small plus small equals big. And so we're going to use that concept through all of this. So we have 26 plus 60 equals our big one, which is 82, or sorry, not 82, I got 86 degrees. Okay? For number 9, when we're looking at find the measure of angle KLU, so we're looking for this angle, we don't know it. If we know that ULM is 20, so we know this one is 20. And we know that KLM, so the big one here, that big angle is 110. So if we think about small plus small equals big, we have that 20 plus one that we don't know. We're going to call that X. Maybe. Sorry, guys. I don't know why that keeps moving. So 20 plus X equals 110, and then we're going to subtract to get 90 degrees. Now, some of you will recognize that without this equation that you're going to subtract to find that answer. That's totally fine. Okay, when we look at number 13, okay, so flip it over. When we look at number 13, we know FCD is X plus 41. We know that BCF is X plus 78. They also tell us that BCD, so the big one here, is 95. Again, we have small plus small equals big. One of my smalls is X plus 41. The other small is X plus 78. The big angle, or the whole angle, is 95. And now I'm just solving algebraically. So as I'm looking at this, I'm going to go ahead and combine my like terms. So I have 2x. Again, sorry guys. We have 2x plus 119 equals 95. And then when I subtract that 119, I'm going to end up with 2x equals negative 24. So my x is negative 12. Okay. So again, our x value can be negative. If we were to plug that back in to check, just be sure the angles themselves are not negative. And when I say plug it back in to check, it's the same idea as the segment addition. If I were to plug that negative 12 in for the angle here, that would give us 66. If I were to plug in the negative 12 to the other one, that gives us 29, and 66 plus 29 does give us that 95, so it does check. Okay, 17. This is the last one we're going to do together. If we look at HIW, that's what we don't know. Okay. Notice we know it in terms of algebraically, but we're trying to find what it is numerically. So let's label what we know. So Wij is 10x. Hij, so the big one, and I'm going to just write big here to kind of keep my mind that that is the big one, is 145. And then we know HIW is 2x plus 13. And so again, we're going to do small plus small. So we have one small is 10x, the other small is 2x plus 13 equals 145. Combine our like terms. Okay, subtract the 13 out of there. And when I do 145 minus 13, I get 132. And then when I divide, we get x equals 11. Now, again, just be mindful, it asks you for HIW. So then we would need to plug it in for x. So we get 2 times 11 plus 13, which gives us 35. And so our HIW equals 35 degrees. Okay, so again, we're using that same concept that we did with segment addition, now just with angle addition. The big thing, make sure you know which angle they are referencing.